All right, good morning, guys. So today we're going to start lesson 10.3. We're going to be talking about two-way tables. The first page is a lot of vocabulary, so I'll read that through with you now. But I will post a copy of these notes, both blank and my answer key, so you can take the time to copy them down if you choose to do so. Okay? All right, so we're going to be talking about two-way tables. That's the first terminology or first definition in your terms. A two-way table is a frequency table that displays data collected from one source that belongs to two different categories. So these are actually examples of two-way tables that we're going to be working through. All right, so we'll talk about those as we get started. Joint frequency. Each entry in a two-way table is called a joint frequency. So each of these entries is referred to as a joint frequency. Marginal frequency. The sum of the rows and columns in a two-way table. So actually we have totals here and there. So these are the joint frequencies, these four spots. And then the totals, so these are the totals of the columns and the totals of the rows. Those are called the marginal frequencies. Then we have joint relative frequency. It's the ratio, so we're going to be calculating those. You're going to be asked to calculate the joint relative frequencies, and that's going to be a ratio fraction, right? The ratio of a frequency that is not in the total row or the total column to the total number of values or observations in a two-way table. Marginal relative frequency, the sum of the joint relative frequencies in a row or a column in a two-way table. And then conditional relative frequency, the ratio of a joint relative frequency to the marginal relative frequencies in a two-way table. So it's a lot of terminology, and understanding the terminology in relation to the two-way table is going to be important, okay? All right, so then what I highlighted is just more of the vocab that we already talked about, okay? So that's there for you. All right. So for our two-way tables, this is what is given, the first two example problems that we're going to look at. This is what is given. And you're going to be asked to complete the two-way table. So to complete the two-way table, you just work backwards, okay? If you're given a total of a row or a column, you got to figure out, well, where can I go, okay? So there's really nothing in this column or this row that I can figure out with only one entry. Same thing here, I only have one entry, so I can't figure anything out. Only one entry. So I have to look for where I have two entries and two entries. Since I have these two entries, and this is the total of the two columns, and this is the total, or of the column, excuse me, and this is the total of the row, I can just subtract and work backwards, right? If these two add up to 130, then to get this, I wanted to use a different color, hold on. To get this spot here, you're simply going to subtract 130 minus the 60 to get your 70, okay? And same thing with this spot. To get this spot, you're going to subtract 130, that's very ugly, sorry, 130 minus the 58, and that's going to give you that entry of 72. All right, once you know those two entries, now I can figure out this spot because these two add up to this total. Those two add up to that total. We didn't even talk about what this data is showing, but we'll talk about that next. All right, so subtracting 70 minus 22 gives me my 48. Subtracting 22 from 72 gives me my 50. And to get the last spot, I can either look in this row, what two numbers add up to 60, or this column, what two numbers add up to 58, and that's going to be a 10. Okay, so now that I have it all figured out, I can see that this two-way frequency table is showing me the arrival time, tardy versus on time, of people who take the method of walking or city bus to, I guess, their job or school or whatever it may be. All right, so there are a total of 72 people who are tardy. There are a total of 58 people who are on time to work. All right, I'm assuming work. There are 70 people total that walk. There are 60 total people that take the city bus. All right, of those 70 people that walk, 22 are on time or are tardy, and 48 are on time. Of the 60 people who take the city bus, 50 are tardy and 10 are on time. Okay, and that's kind of how you read the frequency table. This 130, that's how many people were asked to participate in this survey or asked these questions. Okay. So our next two-way table, you might want to pause the video and try to fill it out on your own before working with me, just to make sure you're okay. But it's the same thing. This is a response of yes, no, and then our totals, under 21, over 21, and totals, that's their age. I don't know what the question was. There wasn't much detail given. All right, but if the total is 30, that means that there was 1 under 21 and 29 over 21. That gives you a total of 30. And it does make sense that those two add up to 25. Okay, now for these blanks, I can't really work this way off of the 29 or that way off of the 24. So I'm going to come over here. I have a total of 75. I can work this row or this column and get those two entries and then finally get the last one. So I'll have a 50 here, all right, and then I'll have a 45. And then now I can either work in this row or this column to get my last answer of a 21. Okay. All right, so that was that. Now we're going to look at example 3, where we're going to create our own two-way frequency table based on the information that's given. So give me a second to erase and set up. Okay. All right, so dry my board off a little bit. The problem says this. A survey was taken of 100 families with 1 child and 86 families with 2 or more children to determine whether they were saving for college. Of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. Organize these results in a two-way table, then find and interpret marginal frequencies. Okay, so we have to first figure out what are the different categories so we know how to set up our table. So the first is family size, right? They organize the people into family size, 1 child or 2 or more children. And then the question they asked was, are you saving for college? Okay, so it's going to be yes, I'm saving for college, or no, I'm not saving for college. So that'll kind of get us started with how to set up our table. All right, so I'm going to start by getting a marker that works. I'm going to start by writing family size. One child. And then what do I write next? 2 or more children. I'm just going to write kids, make it shorter. Okay? And then I'm going to have my total. All right? So that's like the first part of your table. Okay. Next, they were asked the question, are you saving for college? So over on this side, I'm going to write, sorry if I'm in the way, saving for college. And the answer is either going to be yes, no, and then my total again. All right. So then what I have to do is I have to go back through, read the problem, and fill in the numbers that are given, and then work backwards to find the unknowns. Okay? So it says, a survey was taken of 100 families, all right, that with 1 child. Okay, so how many families have 1 child? The total is 100 families. It says, and 86 families with 2 or more. So the total number of families that took this survey with 2 or more is 86. Okay. And then it says, of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. So when asked, are you saving for college, they said yes. Of those with 1 child, that was a total of 94 people that said yes. And of those that answered yes with 2 or more children, it was, what did I say, 60. Okay. And I believe, yep, that is all the given. That's the given. So just like our last 2A table, we'll work backwards and fill in all the blanks. Okay, so we're going to add to get the total. We're going to add to get the total. We can subtract to get this number. We can subtract to get that number. All right, so filling in, you're going to have a 6, a 26. You add this way to get 154. So that means there are 154 people or families that are saving. There's 32 families that are not saving. And then the 186 is the total number of people who took the survey. Okay. All right. So we're asked to find and interpret the marginal frequencies. Okay. So that is these values here. Those are the ones that we want to interpret. We'll just interpret all the totals. Okay. So just next to their total box, we'll write down what they represent, which I kind of talked about as we were filling out the table. So what does the 154 represent? 154 families are saving for college. So 154 families are saving for college. And then what does the 32 mean? That means that no, 32 families are not saving for college. 32 families are not saving for college. All right, and then what do these marginal frequencies mean? Those totals mean? So 100, what's 100 represent? That's 100 families that have one child that took the survey. So 100 families with one child took survey. And then 86 families with 2 or more children took the survey. 86 families with 2 or more kids took the survey. And then finally, 186 total families were surveyed. Oh, my marker is dying. 186 families took survey. All right, and that is it for that question. Okay, we're going to move on to the next one. All right. Okay, so on the next